Howdy. Organized counting, permutations. All right, so when you're going to be counting, there's numerous things that you're going to run into. So I've done now a few videos, and one of the, I guess, key videos just before this was when you're doing organized counting, you have n distinct objects, and you're trying to figure out from those n distinct objects how you can actually order them. And for that, we used n factorial. So if you have forgotten, I'll put up a link up above that. The n factorial, which is basically the multiplication, kind of the shorthand for multiplication of whole numbers that you have in a consecutive way. So you can look at that video before you jump into here. Now, if we do have a certain number of objects and we want to be able to organize them, right, in a particular way, and we're taking all of those objects, then the n factorial works well. So I'll give you an example before I jump into this. So if we had, 5 of these boxes, they're all different colors. So we have blue, we have red, we have brown in there, yellow, and purple. So if I wanted to organize all of this, I have 5 different distinct objects in here. And I could have done it in kind of a few different ways. So if you kind of go back in terms of counting, so I would go, ordering these, and I'm going to take these colors in these boxes, and then how would I order them? So, I could have ordered it the way that it is. So that's 1. So red, blue, okay, brown, purple, and let's say yellow. But of course, there's many other different ways of ordering this. And the way that we would count these up, so in our first spot, so we basically could pick any of these choices. So we would have 5 different ones. And then by the multiplicative principle, so we can do that for the rest. So once we would pick 5, so then one of them would disappear. And then we would say, okay, well, then we have 4 choices for the second one, 3 choices for the third one, 2 choices, and then finally only 1 choice remaining. And if we would do this, if you multiply this out, you're going to get 120. But another way of doing that, instead of doing all of this, if you're going to have 5 distinct choices and you're going to take all of them, then it was much easier. Instead of doing all of this, you could just simply say this is 5 factorial, which is equivalent, and this equals to 120, and that's what we did in that video. But now we don't always, have, let's say, 5 different choices. But what if we only wanted, so from all of these, we wanted to see, okay, so how many different ways can I order these? But I'm only going to take, or reserve out of all of these 5, maybe only 2. So out of the total of 5, I'm only going to take 2. And now how would I do that? All right, so that would have been kind of the question. And that's where permutations come about. So permutations come about from the fact that you want to be able to order from your distinct choices. And in this video, I will make the assumption that they're distinct, that there's no repetitive ones that are the same, meaning there aren't 2 red, for instance, squares in here. They're all distinct. We'll make another video, when they're not. So if they're all distinct, then we do come in to this idea of permutations, and we do have kind of certain symbols for it. So what we do is, we say, all right, so n will represent the total number of distinct objects we have. So maybe 5 of those boxed colored that we have. And then what we do is, well, we can certainly choose or, take all of them and see how we can order that. But what if it's not always all of them? What if it's sometimes less? What if out of the 5 I want to pick 4, or I want to pick 3 or 2 or 1? So in those cases, this is how we would actually make this happen. All right, and that's the symbol that we utilize in counting. So it's NPR, or sometimes it is written as kind of like a function where you have how many permutations do you have, if you have an input of n distinct objects and an output, all right? So this would have been our kind of output within here of r objects, right? And how, in which ways would you actually, okay, be able to change them or order them around. So coming back to this, you know, if I went back and said, well, what if I was doing, you know, I have 5, but I'm going to only take 2 of them. So out of those 2, of course, you know, we could have said, okay, well, I can start writing these nouns. Maybe it's going to be red and blue, or maybe it's going to be red and brown, okay, and so on for all the possibilities, not just with red, but of course, you know, blue and, you know, brown, purple and yellow, and then I would see how many of them would there be. Now, is it going to be the same as 120, okay, as we have in here? Well, not necessarily, okay? It's not going to be. It might be something different, and that's what we're going to try to figure out in just a moment. Now, this symbol, if you're going to be choosing, if r, so if this r right here, is actually equal, so if this is equal to n, so if this is like that, so then we would just simply write n, p, n, and that is just equal to n factorial, which is what we have studied, okay, in the previous video. So now, in general, what happens is that our formula is kind of neat, okay? So our formula is this. So we are going to have this particular formula for, maybe let me just take this out of here. Okay, I'm going to just shift it back down in here, so. And let me just watch out for that factorial there. Okay, take it like that. So if you're going to be choosing r, and r is actually going to be less than this n, then this is going to be our equation. Now, if it is n, then notice what happens in here. So it would have been n factorial all over. Now, this is going to be n minus n factorial, which is going to be 0, right? Okay, so it's n factorial divided by 0 factorial. And here, actually, by definition, we say that 0 factorial is equal to 1. So maybe you have run into this 0 factorial, and the way to think about it is, if you have an empty set, if you don't have any choices, then there's really just one way of ordering them. There is no way, so there's no order at all, and that just counts as 1. Okay, so that's just, you can think of it just by definition. If you have an empty set, there's only one way of being able to order, which means no order at all, because there's nothing, okay, there. So within here, coming back, so this would just simply be, if that 0 factorial is 1, this is going to be equal to n factorial, which is exactly what we would return to just our regular counting if we were choosing all the different ones. But if we don't always choose, right? So if we choose something different, then n, so if it's something, you know, if n is equal to, so as we had right here, is equal to 5, and then we want to be able to have 2, okay, where the orders do matter, then what would have been our answer? Well, based on this formula, so if I would do this, I would have, so 5 factorial, which we know is 120, and then we would have 5 minus, where we're picking just 2 of them, okay? And this would have been that, which is going to be 5 factorial all over 3 factorial, which, as you know from dealing with factorials, this is nothing else but simply 5 times 4, which it would have been 20 different ways, okay, for that example that we just did right here. And this shouldn't necessarily surprise you, because if you do go back to the multiplicative principle for counting, right, maybe I'll put up a link up to that, which was kind of the original video on counting, then what we have is, well, if we're going to be picking 2 out of the 5, so that means we're just picking, okay, 2 different ones. Well, and we know for the first one we have 5 possibilities, And then for the second one, we have 4. So when we multiply it, this indeed is 20, which is exactly what this permutation, okay, is. Now, when you're first getting introduced to permutations, I haven't kind of said it as of yet, but in permutations, order matters, okay? So when you're selecting these and you're ordering things up, order does matter. Now, what do we mean by this? Order matters. What does that mean? So if I go back to our example with these, what do I mean by order matters? Well, if I select, okay, and I make this, okay, these are my 2. So I'm going to make a copy of this. I'm going to bring it down. I'm going to paste it. All right. So red and blue. Now, if order didn't matter, then I could reverse these. I could say, okay, well, I'm going to duplicate. What if I did this? And then I take this and I duplicate. Are these 2 different orders or are they the same? Well, if order matters, if red comes before blue, then they are 2 different ones. So this is 2 different ones. This would count as 1. This would count as a separate one. If order didn't matter, where all you really counted was, do you have a red and a blue? Then it didn't matter if the red came first or red came second. Okay? And that will be in combinations. So you're going to see that when you're going to be watching the videos. But when order does matter, then these are treated separately because they are different. You can think of also as speakers. If you have 2 speakers, so someone who's giving a talk, okay, order does matter. So if the first speaker will speak first and then the second one will come after, or vice versa, those are 2 different orders that you could have. If you were just asking, okay, who spoke, and you would say Billy and Joe, for example, or if someone said, well, I guess Joe and Billy spoke, those would be the same thing. But in which order did they speak? That is where permutations come into play. Because permutations do care about the order itself. And the formula for it, so this is the formula that we have for permutations. I'm going to just copy this for myself, right? Because I'll need it in just a moment. But this particular formula will apply to any. So it is saying, okay, so how many distinct choices do you have? And then how many do you want to order, right? So here is number of reserved or selected objects out of the total. All right, so that R stands for kind of reserved or selected objects that I'm going to take. And then that's the formula. So you can quickly do that instead of actually doing the counting yourself or listing things out, okay, as sometimes is done. Okay, you can just simply say, all right, if order matters, how many do I have in total? How many will I pick from there? And then you can use the formula for NPR. All right. So another example that I did in the previous video, which I'm going to give to you now, is, we had a set, okay, of 1 of these characters, 1 M, J, O, U, R, N, E, and Y. So for those, okay, looking at this, obviously, so M1mjourney, okay, .com is the site that I run. And if I pick these characters, they are all distinct. And if I wanted to know in how many different ways could I order these, right? Then we would say, okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I'm going to be picking all of them, so that would have been just 9 factorial. Or we would say 9, okay, P9, meaning I have 9 in total distinct objects. And I'm going to pick all of them, and I want to see how many different ways can I order them. So that's what this would equal. But if I said, well, what if instead, out of these, I don't want to pick all of them. Maybe I only want to pick 4 of them. So what would that equal? And here is where that formula comes into play. So in that formula, instead of counting everything up, so if this is our formula as so, where n is equal to 9, and we're selecting, okay, we're reserving 4 out of those, Then within here, all I would do is I would say, all right, so this is just 9 factorial all over 9 minus the 4 factorial. And you can plug this in, right? So this would have been 9 factorial over 5 factorial. You can use your calculator with the factorials, or if you remember, right? Because this factorial is going to cancel out. So this is just going to be 9 times 8 times 7 times 6, and you will get your answer. I'll leave that for you. So if you choose to plug this into your calculator, or you very quickly just do that, then that's fine. So those are the introductions, okay, to utilizing permutations and utilizing this formula which you're going to get. So it is just for counting when order does matter and you're selecting a specific amount out of the total, right? So you saw this now with these kind of colors. You know, I picked random, well, not really random, it's 1M journey. So those characters, but I could have said 9, you know, P5 or 9 P2 or whatever it might be, okay? And then you can say, all right, so how many different ways can I order them? That's what you would utilize. Okay, so that's the introduction to counting with regards to permutations. And I would encourage you to kind of go through this and, you know, keep the formula handy in the back pocket. All right, thanks for watching. See you in a future video. Bye, everybody.